So, students, we can use some other interesting regressions here. For example, oil variable, you can see that it is continuous, yeah? And it shows oil rents as percentage of GDP. If we type in this data, histogram oil, we'll see the distribution of oil, yeah? Oil rents as percentage of GDP. You can see that for majority of economies, the indicator is equal to 0. Yeah, or there are only some handful of some observations that where oil rents are higher. Yeah, if we go to data browser, we will see that oil, for example, for some countries is 0. Yeah, and for some countries data is missing. Yeah. Maybe the 0 here is not correct. Yeah, we can replace here zeros with missing values. Or if you are entirely focusing on observations when oil data is available, you can type drop if missing oil. Let's see. First, let's count. Count if missing oil. So in 37 observations, data is missing. Yeah. If you go to data browser, you will see it here. Yeah, data is missing. Yeah, if the oil data is missing, you can see human capital data is. Let's first. So since our main focus here lies on human capital index, we can drop if human capital index if missing HCI, right? So 112 observations deleted. So in this regression, you can see that. So in this regression, data automatically drops where data is missing, at least for one of these variables. So possibly this drop here will not affect this number of observations. Here we can see it. You see, we still have 155 observations. So when we calculate this regression, it is already accounted for. Yeah. HCI missing observations for HCI is dropped from this regression. We can do it here, yeah, drop all of them, and now let's count if missing oil. Just two observations. So let's drop also these 2 observations. Drop if missing oil, and now we have to do something with the cases when yeah, we have zeros here. Yeah, we have zeros. What I want to do here, I want to generate a dummy variable that indicates existence of oil. Yeah, I want to group data. I want to group countries into 2 countries that have oil, that are oil rich, and countries that are oil poor. Yeah, to do so, we will generate oil. Let's call it oil D equals to 1 if oil greater than, let's say, 10. Yeah, where oil rents is above 10% of GDP, we will treat these countries as oil rich. You can see now we have just 15 countries that are oil rich. Maybe we can even change it a little bit. Out of 100, and maybe we can use this. Yeah, so we have 140 missing values. You can go to data browser, you will see it. Yeah, for example, Azerbaijan is oil rich, that's why oil dummy is equal to 1. Yeah, Algeria, Angola, these are oil rich. Chad is oil rich, Congo is oil rich, Gabon is oil rich, Iran, Iraq, Kazakhstan, Kuwait. I think it will show mainly Oman, Qatar, Saudi Arabia. Where is Russia? Yeah, Russia is not even here, and that's interesting. Ah, here. Russia is oil poor. What's oil rent here? Yeah, oil rent is very low. Maybe we should use here a little bit different threshold. Let's drop oil dummy and let's regenerate this. For Russia it was what? I want to Russia to be included in oil-rich countries. So oil is 6 point. Maybe we can choose oil. We can choose maybe 5. So let's use not 10 but 5. All right. So we have added 2 more countries. Yeah. Now, if you go to data browser, you will see that Russia is now, for Russia, oil dummy is equal to 1. So for other countries, we need to have zeros here, not dots, yeah, not missing values. So we have to replace these dots with zeros. To do so, we type replace oil D equals 0 if missing oil D, right? You can see for 138 observations now we have made changes. If you go to data browser, you will see that this oil dummy variable is complete. Yeah, it is equal to 0 for oil poor countries and it is equal to 1 for oil rich countries. We can use now this dummy in our regression. Let's recall our regression, but here I will interact also human capital index with oil. Maybe first we can type here HCI oil D. Yeah. So I'm running the same regression, but now instead of continuous oil variable, I am using oil dummy. Yeah. You know how to interpret the coefficient of oil dummy. It shows the difference in the intercept between the base group, which is oil poor countries, and other countries, oil rich countries. So how you say, how you interpret this coefficient here. So you state that in oil rich compared to oil poor countries, in oil rich countries, GDP per capita will be 62% higher, because here we have log, we have to multiply it by 100. Yeah, so in oil rich countries, GDP per capita on average will be 62% higher compared to oil poor countries. Right? That's how you interpret this coefficient here, and you can build here the two lines. Yeah, if you want to see the effect of, say, human capital on log GDP per capita, you can use margins command. Yeah, let's type margins at comma at HCI equals, let's say it starts from 0, interval is 0.1 till 1, others are fixed at their means. Alright, so by using this command, look at this, I am assigning different values to human capital index. Other variables are fixed at their sample means, FDI and oil dummy. So for now we are ignoring the others. If I type margins plot, we will get a line that represents the relationship between human capital index and predicted values of logarithm of GDP per capita, and you can see this line here. Yeah. Here we are not distinguishing between oil-rich and oil-poor countries, because for this line we are fixing oil dummy at its sample mean, which is 0.1. Here it doesn't make any sense. To fix that, here in this at means command, we should also allow oil dummy to get two values. Oil D equals 0, 1. Right? So now you can see that we are also in line with human capital index. We are also allowing oil dummy to change between 0 and 1. FDI is still fixed at its sample mean, you see here, but human capital index and oil dummy will vary. At the end, if I type margins plot, you will obtain these two lines that are parallel to each other. For oil-rich countries, you can see the regression line predictions of log of GDP per capita stands above the predictions for oil-poor countries. Yeah, because in oil-rich countries, on average, GDP per capita is higher, right? So that's how you use oil dummy in your regression analysis. You see how oil richness influences GDP per capita.